Those are DPs that have to be initialized. You can't compute them based on other DPs, right? For example, in Fibonacci, right? Fibo of 0. Should it be Fibo of -1 plus Fibo of -2? Well, these two don't exist, right? So you have to start with some initialized values in your DP, and based on them, all the other DP values are going to be computed, right? Awesome. So, yeah, basically in Fibonacci, Fibo of 0 and Fibo of 1 are initially equal to 1 as an example, and then starting from Fibo of 2, you will be able to use the recurrence relation. And then step number 4, I won't necessarily write it, it's of course coming up with the answer. After having computed all the DP array, what's the answer? How can we use it to get the actual answer, right? Cool. So, these 3 steps are super important. I'm going to start with step number 1. Here, we first have to come up with the number of dimensions and then with the meaning, right? Well, I'm going to share with you some tricks. For the number of dimensions, what I actually do is that I start small, right? I start and try only 1 dimension. If with 1 dimension I'm able to go through step number 2 and step number 3 and everything is fine, that means that's how I solve the problem. If not, and usually you'll get stuck with the recurrence relation, that means that you probably might need an extra information, which of course converts into an extra dimension. So, let's start with 1 dimension in trying to solve this problem, right? How can I use 1 dimension? Well, it would be DP of I, that we know for sure. But what does it mean? Well, I know that the length should be n, right? Okay, that's interesting. So I can try something like number of binary strings of, let's say, valid binary strings, right? Number of valid binary strings of length I. Okay, everything is fine. Now, if I know how to compute this DP array, obviously my answer is going to be DP of n, so that should be fine. But step number 2, I need my recurrence relation.